Hi, so this is the start of chapter 12, which is really all about non-renewable energy. And first we're going to talk a little bit about types of energy use, both globally and within the United States. And then we're going to focus on the different types of these non-renewable energies and go through and talk a little bit more about where they come from, how much do we have, how long is it going to last, and some of the pros and cons to those different types of non-renewable energy sources. So let's start by looking at how much energy we use right now. So if you look right here at this diagram, this is a diagram out of your book, and it shows that globally we use primarily oil for our energy source, and that we use about 500 what's called exajoules. So remember, we talked about joules in chapter 2. That's a measurement of energy. Exajoules is 1 billion gigajoules, and 1 gigajoule is 1 billion joules. So anyway, this is all the conversions are outlined or explained in the outline for the chapter, so you don't need to memorize all that. Anyway, this is as of 2008, I believe. Yeah, 2008. And right now in 2010, we are actually up to about, I was going to write 2000 again. We are up to about 550 exajoules of energy use. In the United States, of course, we have to be different. It's measured in quadrillion BTUs, which is just a little less than an exajoule. So it's about the same, but that's where that comes from, and that's also explained in the outline. So we went from about 495 exajoules in 2008 up to about 550 exajoules just 2 years later. So this is obviously going to continue to grow as the world's population grows and as we become more affluent. So not too surprising. If we focus just on the United States, it's roughly the same. Again, our energy use is primarily supplied through petroleum products. This would be oil and its distillates, with coal and natural gas being close seconds there. And it's pretty similar to the global percentages. If you just kind of want to remember it that way, it's probably easier than trying to remember specific numbers there. So again, petroleum or oil is our primary source of energy. And this is all types of energy. This is electricity, transportation, industry, all energy is primarily supplied through petroleum. In the United States, you can see that nuclear power accounts for about 9% of our total energy source. Of all the energy we use, nuclear energy supplies about 9% of it, and then renewable about 8%. And if we think in a global scale, this renewable energy number is a little higher. It's about 13%. But that's due primarily to the use of wood or charcoal or manure, cow patties, for energy. And our renewables come from other sources, but biomass also being a significant portion there, as you can see here. So if we look at just electricity, then we can see that coal in the United States is really our major source of electricity in the United States, with natural gas coming in second. Now these numbers, this is in 2011 that I got these numbers from. In your book, I think it's around 2008, something like that. And these numbers are a little different. In fact, coal, I think, is up around 45%, and natural gas is around 21%. Nuclear power, when you look at electricity, obviously plays a more significant role there, being about 19%. Ignore that little thing that just went past there. And then various other renewables that we're looking at, and a little bit by oil, but mostly coal. So total energy supply is from oil, but if you look just at electricity, it's really coal that's generating most of our electricity. And this number has come down significantly over the years. And depending on where you are in the United States, that number is going to be different. So in Georgia, that number is going to be much higher. We get much more of our electricity from coal. So this is, again, on average within the United States. Right, moving on. So to generate that electricity, we use basically the same process, whether we're doing it through coal, natural gas, or nuclear power. The idea is to generate steam. I think we've mentioned this before. So you create some source of heat, whether it's burning coal, natural gas, or through the fission reaction of nuclear power. And that heat heats up water, which generates steam. That steam then turns a turbine. The turbine spins, and that turns a generator. The generator creates a current, and then the electricity is brought to cities through power lines. The water that was created to steam is condensed, and it goes back in, and the whole process is repeated again. It's the same. Whatever you're doing, that is the basic way we create electricity using these non-renewable resources. And if you remember, this process is fairly inefficient. We're talking about 35 to 40% efficiency in general. So only 35 to 40% of the energy locked up in coal is actually converted to electricity. And the rest, heat, right? So that just goes up as exhaust and other forms of heat and is lost. Nuclear power is a little more efficient, but in general, that's what's happening there. Now, there are ways to improve this efficiency through fairly simple means, and actually be interesting if we can actually create a different way of creating electricity using these non-renewable resources other than this fairly inefficient way. And if we can, well, that would be a huge help to extending our energy resources into the future. So one way in which we can increase the efficiency of some of these processes is through the process of cogeneration. And it's a fairly simple idea. The idea is that if you want to, in the process of creating electricity, so let's say we have some fuel, and in the process of cogeneration, you burn that fuel in a traditional fashion to create electricity. In this particular example, it's showing it as 44% efficient, which is fairly good. Now, in cogeneration, what you would do is you would capture the heat that's produced through this process and use it. So instead of letting it radiate out into space, you would either use it to generate more electricity or funnel it into a building or into a greenhouse or something, which would then serve the purpose of heating that space. So instead of creating other energy to heat it, you just use the waste, quote, waste energy from this electricity generating process to then heat your building. So in factories, this can be done quite easily by, again, transferring energy through some electrical process and capturing the heat to heat a building, heat a house, heat a factory. In this process, it's about 87% efficient, and only about 13% is lost as heat. If we look at a more traditional way of doing both of those processes, creating electricity and creating heat, you would take fuel and you generate your electricity, but then you'd also have to generate heat. And in this case, it's showing through some sort of boiler process, which is about 95% efficient. So you burn some process locally, like you burn something like heating oil or something like that, and it generates heat, and you take that heat and you heat the house or the building. So it's about 95% efficient. And then you have this same process to generate the electricity, which is about 44% efficient. So to do the same thing using traditional processes, it would take about 150% of that fuel to do the same thing. So it makes a lot of sense to do cogeneration. And there is a small percentage of our power and, what should I say, not just power, but energy use within the United States that uses this process of cogeneration. It's actually quite common in Europe and other countries, and it's really just catching on in the United States. So for the next few lectures, we're going to go through these different sources of non-renewable energy, many of which we heavily rely upon right now, mostly coal, oil, and natural gas. I'm also going to talk a little bit about some of these other methods, such as oil sands, like the tar sands up in Canada, this liquefied coal technique, which they mention in your book, oil shales, which are becoming more popular in the United States, and then we'll spend quite a bit of time talking about nuclear energy as an option. All right, so I'll see you later. Next, we'll talk about coal.